Kia ora, malo lelei talo falava, kia orana, malo ni sabula vinaka, whakalofalahi atu. Aloha, warm Pacific greetings to you all this evening. O kingo ko Diana, me Aotearoa New Zealand, o ko ta mai mo ko whae Meitonga, me hapai mo vavao. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Welcome everyone to the University of Otago o Tako Whakaihuwaka on this very special and significant occasion as we've come together to celebrate and join together in acknowledging Professor Azam Ali's Inaugural Professorial lecture. Welcome everyone, come on through. Just a couple of mentions to begin with. My name is Professor Diane Sikapautonu and I'm the Deputy Vice-Chancellor Pacific here at the University, and it is a privilege to be able to join you this evening and also to offer just a few words of welcome as well. Acknowledging mana whenua, all of our special guests and visitors who are here in the room, comprised of colleagues, friends, family, loved ones, ainga and gainga, as well as those who are also joining us online. Welcome, welcome, welcome to you all. Down the front, you can see that we, as part of our academic party, we have Professor Paul Cooper, who is the Dean for the Faculty of Dentistry, tēnā koe Paul. We also have Professor Azam Ali himself, who is now a professor in the Faculty of Dentistry, tēnā koe. And last but certainly not least, we have Professor Peter Cathro, who is Head of Department for Oral Rehabilitation here at the University of Otago, tēnā koe. A privilege this evening also to have the opportunity to welcome Professor Ali's wife, who is also here in person with us, and some other family members. So to Rafia Sultana, who is joining us. Now Rafia, down here at the front everyone, welcome. It's great to have you here. We also have Professor Ali's daughter, Sayana Islam, who's also down here as well, welcome. And Professor Ali's younger son, Asif Azam, welcome. It's great to have you here as well, and he's also down at the front. Now, we also have some other special mentions and family members and close friends who are also online. We have Professor Ali's elder son, Nasif Azam, who's joining us all the way from London in the UK, so welcome. Great to have you linked in with us this evening. We also have Professor Ali's sister, Dr. Halim Khatun, who's joining in from Dhaka in Bangladesh. So welcome to you, Dr. Halima. We have Professor Ali's mother-in-law, Mrs. Sayeda Sultana, also joining us from Dhaka in Bangladesh. So welcome to you, Mrs. Sayeda. And many other close family and friends as well. Now, just to mention a very close family friend who's also linking in from Dhaka in Bangladesh, Mr. Farouk Hussain, a very special and warm welcome to you as well, as also Professor Umaru Ishiyaku, who was Professor Azam Ali's PhD supervisor and who was linking in from afar as well. So welcome to you, Professor Umaru. It's an honour to have you all here gathered in the room, but also to have you joining us and linked in online as well, because tonight we are in for a wonderful time together. We will have the privilege of hearing more about Professor Ali's impressive journey to becoming a professor, and also to hear more about the excellent work that he has demonstrated and the incredible achievements across the research, teaching and the service domain areas. I am confident that we will all be impressed, inspired and impacted as we hear more about Professor Azam Ali and about his work that he has undertaken and his contributions that he has achieved. Among the many things that Professor Ali will be sharing with us this evening will include some of his work as a scientist across a number of different countries. So starting off in Bangladesh as an atomic energy scientist, then moving across to the US, working in nanotechnology and as a biotech scientist, and then finally coming here to Aotearoa, New Zealand, and working for ag research, and now with us at the University of Otago o Tako Whakaihuwaka. Your commitment to excellence, Professor Ali, has certainly been rewarded. And on this well-deserved promotion, we congratulate you. And just before I hand over to the next speaker, for those who are here in the room and those who are online, LinkedIn, I would like to ask that we please together acknowledge those who've supported Professor Ali along his journey, and that we recognise his family who are here in the room but also who are online. So everyone, please, could we just put our hands together in recognition of their efforts? It is now my privilege to hand over to Professor Paul Cooper, who will offer a more fuller and further details about Professor Azam Ali's career. Thank you so much for your time. Malo Alpito.
Tēnā koutou, and a warm welcome to everyone here in the auditorium and on Zoom. It is great to see so many people here this evening. It feels like we've only just been here, so it's very good for us to be celebrating another IPL from dentistry. Ko Paul Cooper toko ingoa, no ingarani o ko tupuna, no otipoti aho, kei te kaupakapunio aho, e mai hana e manu taki aho. I'm Paul Cooper. I'm very proud to be Dean of this celebrated and historic Faculty of Dentistry. I'm originally from the UK, and it is my absolute honour and pleasure to introduce today's speaker for his inaugural professorial lecture, Professor Azam Ali. As is usual, I will provide an introduction to Azam. Indeed, to help me, he has already provided quite extensive background documentation, and I see he also has his own Wikipedia page from which I can also draw upon. Azam has a very interesting and varied career, coming from a rural and humble background, and he describes his journey as one of continual change. His education and career has already taken him to many countries, including Malaysia, Japan, South Korea, the USA, and finally New Zealand. Azam obtained his bachelor's and master's degrees in chemistry from Jahangir University in Dhaka, Bangladesh in 1988 and 1991 respectively. In 2000, he obtained his PhD in polymer science, engineering and nanotechnology from the University Sans Malaysia. He then worked as a postdoctoral research fellow in materials science and engineering department of Pohang University of Science and Technology in South Korea. Azam then went on to undertake postdoctoral research in the chemistry department of the University of North Carolina in Charlotte in the USA, where he worked until July 2003. He then came to New Zealand and worked as a senior scientist and biomaterials research lead at Ag Research in Christchurch up until April 2013, before joining the University of Otago as a senior lecturer. Since joining the university, Azam describes his journey as also being one full of change. He began his career at Otago in applied sciences in the Department of Textile and Clothing, focusing on teaching and researching into fibres, polymers and engineering materials, as well as establishing the bioengineering academic program, which started to enrol postgraduate students in 2014. However, unfortunately, the Department of Textiles and Clothing was disestablished in 2014, and Azam was then transferred to the Centre for Material Science and Technology. Unfortunately, this was then disestablished in 2017. Azam and the bioengineering program were then relocated to the Department of Food Science. In February 2021, the Department of Food Science was reviewed, and it was recommended that Azam and the bioengineering program be again relocated, but this time to the Faculty of Dentistry. Hopefully, this disestablishment and relocating battle has settled for a while, but as Azam has shown, you never know what's just around the corner. Azam has received numerous honours and awards throughout his career, including the Bayer Innovator of the Year in 2010 and twice being Otago's Supervisor of the Year in 2018 and 2024. He has led over 30 major projects and secured around 13 million New Zealand dollars in funding to support his research. Azam has supervised more than 68 postgraduate students, including PhD, MSc, PG diploma and honours students. His work has produced 24 patents, and he has invented 6 medical devices, now used in 23 countries around the world. His research outputs are equally impressive and include over 190 full publications plus 12 book chapters. Outside of research, Azam plays an active leadership role, serving on New Zealand wool boards, journal editorships and editorial boards, and reviews for journals and funding bodies. He has examined numerous PhDs and master's theses from around the world. As a dean, I'm extremely grateful for Azam's adaptability and how he has integrated into the faculty, taking on teaching into both dentistry and dental technology programs, as well as teaching and supervision in the DCLIN-DEM program. I know family is very important to Azam, and it's great to welcome here today his wife Rafia, daughter Sayana, younger son Asif, and watching online from London or maybe Turkey, his eldest son Nasif. Other family members will also join from Dhaka, including his sister Dr. Halima and mother-in-law Saida. Welcome to you all. I'm sure Azam will also have many more family and friends who will watch the lecture from around the world and who also will be very proud. I'm not sure how he fits everything in, but I'm also aware that he attends the gym down at Unipol most evenings. So therefore, I believe he's giving this a miss tonight, unless he plans on going after his lecture. I suspect that we are in for a very interesting and entertaining and inspiring presentation, as Azam has informed me that his story is not just about science, but about turning challenges into opportunities, allowing him to grow stronger with each step of the journey. So please join me in welcoming Professor Ali to the lectern to give his IPL, intriguingly entitled Journey of Wool from Concept to Clinic. Tena koutou, tena koutou, tena koutou koutou.
Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious and most merciful. Good evening. Assalamu alaikum. Peace be upon you. Thank you, Professor Diane, for your nice introduction. And Professor Diane is a VC Deputy Vice Chancellor, University of Otago. Thank you, Professor Paul Cooper. You cover on my summary of my CV and highlights. So particularly the challenges I have been encountered and adapt and resilience I have shown, that is one of the part of my today's journey. And Professor Peter Cathro, Head of Department, Oral Rehabilitation, Faculty of Dentistry. Thank you. Good evening. Thank you again, my dear family members, those are here in person, colleagues, friends, collaborators, dear students. Thank you for your time, those you are in presence in here. Those you are online, I really appreciate for your time and efforts. I'm really grateful to all of you. Those, I would like to extend my thank you for those you are watching in future for this video. I would like to thank you to all. So start to my talk, Inaugural Professorial lecture. I outline my personal journey, education and career, and also the research journey. I'm going to focus more and accomplishment and award, also the finally acknowledgement. To begin, who am I? So I born in village in Bangladesh, northern part of Bangladesh. Many of you don't know Bangladesh, but now many people know about cricket. So the cricket is growing now in Bangladesh, but anyway, my hometown is northern part, they call the Bochagons. So this is the area where I born, this is my hometown. This town is famous for sugar manufacturing and also paddy and rice. In fact, my grandparent and parent actually mostly they own a lot of land and produce paddy, and many of my family member business is in processing of paddy to rice. I supposed to be an entrepreneur, but unfortunately or fortunately, I was passionate about my education. Therefore, and my mom was supportive with me to do higher study. That is the main motivation as well, because the culture was more on entrepreneur type of things and agriculture production. So anyway, this is me, little Azam. And my parents, my father and mother, and we have 10 siblings, 8 brothers and 2 sisters. These are happily married and living in my country happily. My elder brother's age is now 72, so I'm a 5th. My younger brother actually came in 2005 in New Zealand and stayed a couple of years, and I don't know why he did not immigrate in here. He returned to Bangladesh and happily living there now. Otherwise, he will be one of my, the closest family member to New Zealand. Anyway, my schooling in my hometown, they call the Bochagons, that's called Shatabganj Pilot High School. This is my old school. I found this photo, and this is now is a growing, it's a very big school and top school in our location. It's about 5,000 students. So I finished my secondary school certificate from this school, then did very well, and then motivate me, and my mom actually pushed me harder to go to the top college in Dinajpur. This is the top college in our northern part. There are 2 good colleges that time. This is the one, and another was Carmichael in Rangpur, another city. So that was my start for higher secondary study. The interesting thing is that I have to stay in the dormitory. This is the first time I away from my comfort life to this hard life and difficult life. I have to do everything myself. Although I have to do many things, but every week I back to home with my dirty clothes, clean, and servant can ironing, and back again. This is my everyday. And I was not very well often when living alone. But anyway, despite all these challenges, I did very well in my higher secondary. So it confident me enough, motivate me, proud my parents. And my parents again pushed me, you should go to the capital city, which is the mega city, 23 million people now living there, to get a chance and get admission in this top public university. And as I said, in Bangladesh, 170 million people countries, every spot you need to secure, you have to have a very competition. Even getting admission in this university and other university, I secured 2 positions in the Department of Statistics in the Dhaka University, and this university, chemistry, physics, and statistics. So I selected chemistry because I love chemistry, and also I made position is 3rd in this admission test. And admission test was very, very competitive. 1 seat, you have to compete for 904 at that time. So it's a very, very competitive. Another thing is that this university is beautiful, very greenish, lot of lake, and currently that is used as a tourist spot. So everybody goes there to visit there from capital city to there, about 30 kilometers. And beautiful gate is now there. That time there was no main gate. This is the nice university. Again, I have to stay in the dormitory. This is the big dormitory. 460 students live in this dormitory, and I spent 7 years in this dormitory during my bachelor and also the master's. It's supposed to 6 years degree, but it took 7 years because of some political unrest and so on. But anyway, after completion my both degree with first class, I was thinking, what should I do? I in a process for finding a job, and I was confident I can get a job, but I was interested to have a job in this capital city. So in the meantime, I had some relationship with my classmate, and I was, after finishing my degree, I was thinking to marry first before finding a good job. So what I did, actually, I was hesitant to tell these things to my parent, what would be reaction, but one day I was brave enough to call my parent and said, I'm going to marry one of my classmates. And reaction was, my parents said, when? I said, as soon as possible. They said, okay, I'm going to talk to your brother and let us know their contact, we can communicate and make things happen. And then after a few months later, they traveled to Dhaka and make things arrangement with the 2 family, and our wedding is completed, and we live in capital city. Good thing also, my wife in the meantime secured a job in a population council in one of the research institute, and she started earning. Also, I know my parents will support me. In fact, they support me, including all expenses for my wedding. That is great. And that was my start for my family journey. And our firstborn baby, Nasif, was born in 1994. And before that, I already secured a job, number of job actually, but most of the job was outside the capital city, which is not my interest because my wife in city, I don't want to go anywhere. So I was waiting for other in the process for my interview, and subsequently my dream come true. I secured a job as a scientist, they call scientific officer in the top organization, prestigious organization, Atomic Energy Commission, as a scientist. And fortunately, my placement happened in this institute they call the Institute of Nuclear Science and Technology. That is a highly prestigious institute. Only one nuclear reactor in this building, and all the scientists are overseas scientists, has a PhD holder, and a lot of equipment and facilities donated by the International Atomic Energy Agency, those you don't know, from the Vienna, and a lot of training facilities. At the same time, I was super lucky that my mentor, Professor Idris Ali, he worked a lot in Lead University, also International Atomic Agency. He was on that institute as a chief scientist, returned to Bangladesh as a Bangladeshi scientist. So he was our main boss and working on the material science and engineering, radiation physics and chemistry. That was actually the main foundation of my research inspiration and the motivation. And the group was super. We published a lot of paper at that time in a developing country due to these facilities and our mentorship. And one of the top scientists still in our country, he has a highly regarded in my colleague. Anyway, that is my start for career. Then what happened? To retain on this institute, to perform well, get a promotion, you have to have a higher degree. Otherwise, you cannot stay as a high performer. So, and culture of this institute is most of the scientists are PhD holder. So I start searching a good school to get a admission. I secured admission in Michigan State University in US and also the Memphis State University. Unfortunately, I did not get a full funding. Only I get a partial funding from Memphis State University, and the topic was not very good, and I was declined. And wait for a while and start looking for an opportunity. Then one opportunity come from international funding agency, they call JICA, and Malaysian government. Working space is the utilization of palm oil co-product is making new materials to make it value added. Those are my friend in here in Malaysia, they knows the palm oil board and palm oil research is a highly rich institute, and they funded a lot. So I got an interview and compete and get this position and move to Malaysia to work in here. Also, I had the opportunity to work in Japan because it's a joint project. So, but I selected Malaysia because of food and other cultural purposes. Anyway, the specific topic was prepare a new pre-polymer, which is the resin, natural resin from epoxy palm oil. When process the palm oil, they produce a lot of epoxy as a co-product. That is not much use. So that was the main focus of my PhD project. But it was a unknown things. And unfortunately or fortunately, I selected this topic, and I went there and start hard time in there. So I was 1 year, I did not get anything. Every time I start working, it decompose the materials. And it was so hard. And I can just give a brief summary about this, what happened. We started from many, those are the chemists, I don't want to distract you. It's a big step to do these things. Every time somewhere is decomposed, cannot produce the ultimate materials. But at this time, finally, one day overnight actually, I was in the lab, drop was putting the chemicals, and reaction was maintained with condition, and multifunctional acrylated pre-polymer resin is produced. That time is a natural resin, which is nowadays people call bioresin for 3D printing. This is a UV curable, and fast UV curable actually is a multifunctional. Anyway, I don't want to distract for chemistry, and that paid off my PhD work as a first patent in my research. That was a completely new, and that is now used a lot for making foam, making bioplastic, coating, and so on. So that is the first motivation for my patenting and applied research. I was, in the meantime, got a lot of opportunity for postdoc in South Korea and US. So the South Korea project was very interesting. Nanomaterials and nanotechnology that time is a super hot topic. And the stipend was quite high on that time as a postdoc compared to US and other. So of course, both as interest. And then what I did not attend my graduation. I was absentia. And then after finish my postdoc, before going to US, I was actually returned to Malaysia to on the way back my country to see my supervisor. And my supervisor actually is so happy to see me. And this supervisor, Professor Jainal, he is now retired, he offered me, I can organize a gown, you can take a photo, and that has happened. I thank you, Professor Jainal. As I said, I secured a postdoc, and the first postdoc one in South Korea on the materials, nanomaterials, nanotechnology. It was a quite hot topic for semiconductor industry. That time, if you remember, it's booming in semiconductor industry. Second postdoc, I secured on the University of North Carolina, and the same topic, similar topic. And that was a joint big project with the University of Wisconsin-Madison and Georgia Tech. And that offered me a lot of opportunity to work on this topic. And I was working on these new materials they call the nanophotoresist. These are the is a flexible unit. This is the chemically acid chemically interactive materials to generate ion, and this is the POS, which is called the MOF, Metal Organic Framework, that is this year got a Nobel Prize. So that time, this kind of materials, this was hybrid materials, organic integrated hybrid materials to actually achieve the functionalities to absorb the ion and generate a lot of, the reaction to create a nano pattern based on this ionization. So to test these materials, I have to coat and make a thin nanolayer. If you remember, nanolayer means 1 nanometer means about billions of meters. It's a very, very tiny. You cannot see even in high magnification of scanning electron microscope required. So that materials is successfully can coat a 6 inches wafer to 12 inches wafer for semiconductor silicon wafer. So to test these materials, I have to travel to Wisconsin-Madison. This is called the Synchrotron Radiation Center. This center is a high-tech. It has a half-kilometer diameter of these facilities. There is a number of beamline. Those are the physicists. They know the X-ray beamline, extreme ultraviolet beamline, UV beamline, and many beamlines. So each people work in a beamline, and I was actually working closely in a beamline they call the extreme ultraviolet beamline. So what does mean that I have to test these materials to fabricate a nano device to put a wafer after coating. Then beamline is 30 nanometer beamline. It's a highly strength. To bombard this surface, create a pattern in there, and then test this pattern for high-tech ACM, scanning electron microscope, TEM, and AFM type of equipment. That actually give a lot of opportunity to interact with the world famous scientists coming from Europe and others. And the director was the Serena. He's a famous nanotechnology scientist in Wisconsin-Madison, and he's the director for there. And his background was more on semiconductor industry. So what happened, we can create a very nice pattern in there. This is called 80 nanometer to 100 nanometer that time. And that allow you to billions of transistors you can assemble in there to make a nanochips. Currently about 32 nanometer, that is why you are getting trillions of nano transistor and nanochips you are getting for your mobile other things. So anyway, that material is actually quite interesting. We published a lot of paper as well as granted to patented. So that is the way my patent, what Paul says, thank you for 24 patents is generated. I'm not sure a lot of innovative work has happened in my journey. Also, I build up a lot of skill, knowledge, tools, hands-on, and so on. So what next? There was a lot of issues in US that time after 9/11, visa issues, my family wishes, and all kinds of things make me a little bit uncertain. So, and at the same time was planning to travel to New Zealand because my cousin was GP in Auckland. He encouraged me to visit beautiful New Zealand, but at the same time it's worked together. And then one day I found a job advertisement in Wool Research. They are looking for biomaterial scientist or wool scientist. And then I old my CV and start working, and I secured the job at the Wool Research. That is my history to come to New Zealand with my family together. So we arrived in 2003 on July 7th. And 6th of July, there was a heavy snow in Christchurch. Welcome was when we landed in Christchurch airport, completely white in crash test. We thought where we are coming. Looks like is the country or something else. And then we arrived in there very cold from the hot country. But anyway, so my first job was in Wool Research Institute. That has, when I joined, after a few months later, they changed the name of Canasys Network Limited. I said, what is going on? But anyway, that's the job is same, project is same, everything's happened, signboard just changed. Then after a few years, about 5 years later, that Wool Research also destabilized, and Egg Research is acquiring this institute. Egg Research is a big one, as you know, in New Zealand. So, but the project was same, and I have delivered a number of projects, but main project is Journey of Wool for make it wool more value added. So this is the journey of wool started concept to clinic. Beautiful New Zealand, and you can see the millions of sheep in there. When my boss picked us from the airport, he's talking about, and we see only the sheep is there, nothing else, as from the Christchurch airport to the Lincoln. And then he started chatting about this, the project, and I also have some idea about the project. He said, main project is wool is only used for carpet and clothing, a textile, because it's New Zealand wool is a coarse wool, no use, low value, and that is the main funded project where I have to work. And that also inspired me, motivate me to do my research to can wool make added value materials. And my background is biomaterials. Always I'm looking for create the biomaterials which will be medical and it will be expensive, so it can be high value. That is my motivation started. So I learned a lot about the wool before I don't know anything. So wool, farm, and also the sharing, extraction of fiber, spinning, and all kinds of things. And then my hypothesis, I put it there, let's say, to make it product for a novel product for biomaterials as added value biomaterials from wool. But my background is not math for one thing. So understanding of wool fiber is my lack of knowledge. So I have to spend a lot of time to understand the fiber science. And biotechnology and process engineering is a kind of expertise, but my core expertise is material science engineering. Therefore, I was just started to prove my prove my hypothesis in a way to first understand the wool. So if you know the hair and wool, their top surface is very hard because of disulfide bond. And when I look at the inside about the anatomy and cross section for the wool, you will be surprised. If you see the microscopic view on your hair, you will be surprised that how their geometry and architect, how the molecular, biomolecular rearranged. So if you look at the magnification of the anatomy, you can find the cuticle, subcuticle, exocuticle, and if you look at the inside, there is a lot of fibril matrix, the fibrous matrix. And if you go even further down, you can say intermediate filament protein. All are disulfide bonded and is strong and flexible as well as strong. The arrangement of the molecule are completely natural. We call the biomimetics. Anyway, I have some understanding all these things last 22 years, and I can talk more about this, but today is not the time. Then I will look at in details about the molecular and cellular level, particularly interest about the intermediate filament protein. If you look at that more bundle about the helical and the crystal structure of complete amino acid. And if you know the hair and wool has more than 86 to 90% of, depending on the types of materials, you can get a lot of protein materials in there, which is amino acid. Anyway, so there is a group already start working on that to separate the protein molecule and to digest the different type of wool. As I said, the wool has types of different and coarse and so on, does not matter. The chemical process actually cleaves the disulfide bond different way, and that is called the sulfurilysis process to digest that and make a solid fraction and the liquid fraction. Our interest was in liquid fraction. That liquid fraction has a disulfide bond is breaking, it can make is low sulfur and high sulfur. High sulfur going to use for medical, low sulfur going for other application. So anyway, the low sulfur, the separated solution, soluble fraction has a base, and then when you acid precipitate, they get a solid, and you can separate that as a powder. And this powder is fully cystic protein, cystine protein molecule. And that is the main keratin materials at this moment. And these materials is my strength is that manipulation. It's a reconstitute of these materials is my main job to make a added value. However, I need to understand more details about the structure. Still there is a disulfide bond. Also there is other kind of ionic bond which I need to manipulate to make them processable to make evaluated materials. But anyway, also I have done a lot of work on the wool keratin structure understanding, and that result actually tell us it's quite similar with the collagen, and collagen has a lot of potential to use in cosmetics, personal care, and medical air. Therefore, we get a lot of eureka that can make these materials is a huge potential as a biomaterials. That is the clue for that. And again, generate a lot of patent in US and EU. So this is the way it's happened, all the innovation in my journey. Next, we got a big grant, multi-million dollar of grant for this project, and from coming not only the government, also wool research. Keratech in the meantime build up a company on this, based on this as a manufacturer. The multi-million dollar fund is coming. That is why there's 12-30 million in my portfolio, because I maybe generate about 7 million out of there. It's a lot of funding is coming from this project. So purpose for main objective, regenerative wool fiber. What does mean that we have to make a fiber wool similar to the merino wool, fine wool that can be used added value. We produce this fiber. There is no problem even in laboratory setting as well as mini pilot scale setting. Problem is that mechanical properties. We managed to make a physical and other properties, flexibility, looks like a fiber, wool fiber, and diameter also fine. Problem is mechanism, not close to even in wool. Natural materials wool is very, very strong. Here, very strong. So that gives us the uncertainty about the success of this project. Since I had weakness about the biomaterials, so I pushed my boss and the director in the center that can we transform that materials to make a biomaterials. And inherently, I start working on there and generate number of materials in the lab and try to show my boss and convince. And in fact, these are the materials we actually eventually produce. This is the hydrogel materials, look like a honey. This is the protein membrane that used later on as a coating or layer assembled with the foam for medical. And this is the foam matrix. This is also the foam for different structure. Anyway, so I want to highlight a few things because I cannot tell details. That hydrogel materials, when you look at the inside of the hydrogel materials on freeze drying, it given a huge information. What does mean this is a natural biscaffold, three-dimensional structure. CT scan showing three-dimensional interconnecting porosity. This is the natural materials showing this kind of properties, which illustrate that materials has a huge potential as a soft tissue engineer. This is my background also, the tissue engineering. Therefore, I try to convince that to use this one, we did a lot of in vivo, in vitro study. I cannot present all these things, but what I'm highlighting, that materials, actually we did a 45 patient is chronic wound. This is not a normal wound. Chronic wound is a diabetic wound, deep wound. So we tested in a nurse mode in Christchurch, and this is the result for 78 and 85 days that you can see the completely regenerate the soft tissue on the top of this thing. This is the unique outcome from this result. And then subsequently, we produce a number of prototype, and due diligence happened in Keroplast in a US company, and business done. And it's now commercialized for many, many countries for these three products. And also generate a lot of patent, as I said. And this work actually highlighted me, and I secured a prestigious Bayer Innovation of the Year. You know, the Bayer is a German big company, billion-dollar company for medical and pharmaceutical industry. And this is the Prime Minister Chief Advisor and the CEO from Germany. He came, I received the award from them. That's the one of the journey from my wool to from concept to clinic. The second example is here to make an orthopedics implant. Again, my understanding, skill, knowledge, and strength of my knowledge on manipulation and reconstruct the wool protein. So I actually converted the functionalities of the wool protein, and then it has a monovalent. Those of you are the chemists, you know that this monovalent sodium, I make a solubilize and then put it there, or building block of the bone, which is the calcium sulfate, calcium phosphate, so calcium can easily exchange and make a new materials they call the composite, biocomposite. Again, if you look at the inside, we did a lot of work anyway, just I'm showing quickly. This is a bony structure. When you look at the scanning microscope of the composite, you can see the 60-40% ratio of the keratin and the bone-forming materials, hydroxyapatite, to make a bone-like structure. And if you see this interconnecting, that can easily vascularize and regenerate the bone. And we developed and designed a bone screw, which is completely reabsorbable in the bone and regenerate the bone tissue. This work actually did a lot of in vivo study, big animal study in Otago University subcontract, our collaborator, George Dias. George Dias did a number of trials in the air in a big animal and shown very good and evidence based that keratin can reabsorb, make a new bone. This is the 8 weeks only result. He has done a lot of trial and evidence based, and finally that work was produced a lot of patent as well. And these are the prototype design, and those are the actually already approved regulatory and waiting for commercialization for this bone implant. So that impact a lot in the wool industry, and subsequently produce a lot of manufacturing company in here, including Keroplast, Kerotech, and recently last year there's a world leading keratin manufacturing company in Christchurch. What they are doing, 300-ton wool they can process to make a tons of wool powder. And that wool powder is a very valuable for cosmetics, personal care, and also medical application. You may see in the many products in the grocery or the departmental store use the shampoo and other application. This is the keratin coming from there. So you say now it's a multi-billion-dollar type of industry and selling the product in globally. Now, next, after finish my wool journey, I was working and I established a good lab in egg research, biomaterials lab. And I was inspired because a lot of students I supervised, from summer student from Canterbury University and also Otago University, and also co-supervised on student from chemical engineering department and mechanical engineering from Canterbury. So I love to interact with the students. I hope my students know that I love to interact and talk more. And then that inspired me to have a job in academic area. So one day I saw an advertisement in Otago University, and I start emailing my boss, who is Rachel Lang. Maybe she is in here, I don't know, but I'm understanding the job description, and this is the first time I started applying a job. I was not sure what kind of job description is there. So job description said I have to work in a fiber science area, material science area, and also develop the curriculum for the biomedical engineering, the program. So I think it's quite nice and aligned with my the interest, and I apply and I shortlisted, interview, and secured the job. And I came to Otago in this building in my office first. Is a applied science building in here as a senior lecturer. That's my start in 2013, 1st of May. I resigned actually egg research, and there was a lot of noise that what for. And I was just thought, no, my interest is I'm going for academic. Anyway, that's my journey to come to Otago. And as Paul said, that it started in here, moved to here, food science, repositioning in dentistry, the history already he said. I had a huge resilience. I have a lot of challenges I encountered, but all I accept as a opportunity. I don't want to tell many details, but the opportunity, how I turned that opportunity and is still surviving, and our bioengineering growth is considerably quite good. It's sustained growth, students, 68 to 70 students supervised, and we are so happy. And now we actually, thanks Paul, and department is supporting us a lot. We are pretty good blend. Anyway, next 15 minutes I'm going to talk about 10 or 15 minutes about the journey to the University of Otago. So as I said, I started from here. And good thing is that when I joined in clothing and textile department, I did not get any funding from university. Rather, when I came from agriculture, resigned, my funder, industry funder, said, well, I'm going there, so how about your project? I said, I don't know, I'm going there. They said, no worries, we want to fund in Otago University for this continuation of project. So my fund automatically come with me, and the project was super hydrophilic wool to make absorbent materials. That was the first start my project research. So what I have done, so I had enough knowledge in wool. As I said, almost 10 plus years, I had gained a lot of knowledge how to cleavage the wool, not in a cleavage as wool, inside of the molecule, disulfide. So I precisely, selectively cleavage the disulfide bond, not only the surface, also the inside. What does mean that I make a super hydrophilic. When you, hair and wool is a hydrophobic, super hydrophobic. When you cleavage them, then make it hydrophilic, make it ionic and functional. So it absorbs a lot of water. What also done is selectively inside. So you can see this is the defibrillated. The matrix protein I have cleavage. So what does mean that also hold the water. So water absorption is one thing and holding capacity is another thing. So that means if you absorb the water, it can often drop, but this one will not drop. So that is the uniqueness of this work. You can see the 1400% of water can absorb and hold compared to 300 only. So that uniqueness given this opportunity to create a new product that is called, the super absorbent materials used for nappy, baby nappy, also the incontinence is a big issue is for elderly care. So that is now actually commercially available in the market. The generated 5 patent, global patent, and granted, it started from 2013-14, is 22, is granted many patent in there. And I'm very pleased that the manufacturing company established in New Zealand at this moment. They are selling this kind of product now. Also, I did a lot of work in there. I have not time to cut. So one is that elderly care textile sensor to elderly care to measure the ammonia urinated in the elderly care. So that is an interesting topic. Second one, collaboration with my collaborator, Professor Aladdin. We started, when I came, he welcomed me actually with a project and worked together with a fantastic student, PhD, to create a new materials for bone tissue engineering, so which match together. It's a chemical type of strength, and I have a biomaterial strength. We make a tissue engineering type of bioengineering type work. And this is the 3D electrospinning scaffold from skin tissue and wound dressing from Tajul Islam. He is now associate professor in back home. Mina Rajabi, currently postdoc. She completed bone tissue engineering to create some scaffold in there. So as I said, that there is a lot of challenge to move from there and then move to food science. Again, we started what we're going to do food science. But in the meantime, our bioengineering program is progressing well and sustained growth. That is good one and good strength. So what does mean that food science, then I secured one funding from Callahan Innovation and also the government funded subcontract. So the project was dairy co-product for novel biomaterials. If you know that dairy produce a lot of milk and milk powder, and also they produce millions of liters of wastewater when they cleaning the factory. And that wastewater contain a lot of oil and fat and other materials, is solid matter. So that is called the dissolved air floating solid, which is low value, no use. Even dumping these materials is costly, and this is also not value. So what does mean? They need an added value product from these materials. That was our project, and we precisely developed some new method to process them to destroy the micelle bond within this milk. As you know, the milk protein has often micelle, so destroy the micelle, introduce some new molecule in there to process them, make a bioplastic like chips. We produce this one is a protein and polysaccharide based chips, and that has a lot of potential in food for animal and others. In fact, one of the companies producing that product at this moment. Kate Ryder from biochemistry, she enrolled for bioengineering PhD student. She completed now. She is a senior scientist in one of the German biopharmaceutical company. Produce a lot of publication out of is there. The latest one, Dr. Shubha Bhaumik, he is here. His project was smart and functional packaging. As we work in the food science, we are not working on the food, we are working on the plate. Always I said that we are in the plate side, in the packaging and others. So his project was, packaging side. As you know, that milk spoilage is the biggest challenge and biggest loss in globally. It's 150 million million liter often lost for milk spoilage. And those spoilage cost about $64 billion, if you can think about. So there is a process to measure the spoilage, but you need a more instrumentational, costly, and takes time. There is a lot of gadget come in the market, in particularly US and the European market. Therefore, this use for testing quickly. But the problem is electronics component. That component actually nowadays recycling issues. Therefore, our idea come to make a litmus-like type of small device which can easy to use because our strength of bioplastic to preparation. What Shubho has done also extract some bioactive molecule that has a active functionalities to make a biomarker. So with the pH sensitive as well as volatile sensitive, we call the CIM, chemically interactive materials. That add in here, when you expose this in a volatile or the pH sensitive, they change the color. This color can easily identify within 1 to 2 minutes whether it's spoilage or not. So that is a fancy outcome and innovative outcome from this project. And we presented this one and how we submitted an IP disclosure for the patenting and also in process for the commercialization in the company. So they suggested also these materials can also use directly assembled into the packaging in the lid. So people can see from the lid whether it's spoilage or not. That is a cool outcome from this technology. Also, this can directly create some barcode within this packaging system so people can see from there whether it's spoilage or not. So these are the outcome happened from this project from food science related. And achievement was, again, we have a lot of publication and postgraduate students to awarded from this type of work. And in fact, when I was a food science, our group was quite rich. We generate a lot of funding. That is why the PVC Science actually upgraded us, our lab in the Mallow lab. It's a very new lab, brand new lab. We was enjoy that lab for a couple of years. But again, due to the what is called the reviewing of the food science, as I understand, although I don't know details, one day PVC Science come to my office in Mallow lab and propose that your work and the bioengineering growth is related with the health science, and you are quite matched or aligned with the health science. Therefore, leadership team decided to repositioning in the bioengineering and work to the dentistry. And dentistry dean and also the PVC health science are happy to host for your repositioning. Think about, let us know. I talked to my colleague and the team member. Everybody upset and also the uncertain that what is going on. But I was also upset but not worried, because in the meantime, as I said, I developed a lot of resilience, and therefore I thought it is it's considered as a opportunities. So, but in the meantime, I have done a lot of collaboration with dentistry, with good collaborator, with the clinician. As a result, I was easily to blend and interact and make myself or our team in adaptability and blending together. And then we developed a number of projects and collaboration. And we also extended this work to make a bone graft materials for tooth and dentin regeneration. That project is continuation happening at this moment. We submitted a big grant for government funding. Unfortunately, we go all the way to last stage, but it's not funded, but we come up with a good recommendation for resubmission. We are in process to resubmit. So we had done a last year with some in vivo and implanted these materials, and it's showing some sort of dentin regeneration in this project. And it has a lot of media attention on the ODT to regrowth of the tooth from these materials. This is another new materials is come to our in portfolio. So this is the achievement in dentistry. Supervise a lot. As Paul said also, I am also involved a lot of supervision of dental declined dent students, and also the teaching for dental students, DTech dental technology, also the orthodontics type of students. I thoroughly enjoying my teaching based on my expertise. There is some highlights about my academic capacity. I don't want to go through because many committees I am in a board, and also the review committees for curriculum, funding. More importantly, I am still leading the bioengineering academic program, which is sustained growth and lot of supervision also ongoing. And I have got a 2-time Supervisor of the Year on 2018 and 2024. And these are some highlights about my achievements and award. Particularly, I like to highlight this one is Pierre Prasad Academy, which is I recently got last year, and that is the award based on outstanding contribution or work for dental areas. So that actually pleased me, and thank you for the academic that actually extend my award list, so which is the new area. I am so pleased and grateful. Finally, 1 or 2 minutes, I am going to acknowledge my family, because as I said, when my family came in New Zealand, it was very little. And we rented a big, actually, house, 4-bedroom near to the Lincoln, but area was, they call the quarter. And everywhere is a fruits, and also the beauty is that lot of rose garden in there. We thoroughly enjoy that rented house at near to the Lincoln Christchurch. And this is my lovely wife, and we this is my 2 boys. They grown up in here for school, high school, and university. And elder one, as I said, graduated from Canterbury, then Harvard, and then he worked in here in New Zealand. Now he's in London. Second one, younger one, he graduated from here, and just 2 years ago he graduated. And this is my family, 2 sons, and my lovely wife. And my wife actually has a severe issues about the health on lung and heart diseases, and she passed away in this hospital in 2018, and just before Christmas. That was a very hard and difficult news for us, despite there is a lot of challenge happen in my journey for academic and research, but she has supported a lot all the way to this journey, and she was the part of this journey. I actually recognize, not only recognize, pray for her forever. And then I was alone for a while, and a few years back, end of 2022, my new family came to New Zealand, and we are happily living together. Thank you for Pia to support now all the way, and we enjoy each other. Of course, acknowledgement goes to my dear students. Without them, I will not be here today. Their contribution is huge. And some of you are here in person. I'm really grateful for your all support. As I said, 68 to 72 students graduate from bioengineering under my supervision and co-supervision. And these are the postdoc work together. And I think I have to highlight Mary. Mary worked 8+ years with our group. And not only he worked with me, she worked with me. She looked at a lot of students, and I am really grateful for Mary, and her contribution is actually a lot. Of course, acknowledgement goes to my collaborator, my supervisors, and those are the supervisors from Rob Kelly, Elisa, Gart Carnaby, Rachel. I will never forget your supervision and leadership, and Cheryl, Sarah. George Dias was my first collaborator when I was in Agri-Research. Aladdin also was good collaborator. Still, we do a lot of collaboration in a different way. Indra, Dominic, actually many. And recently, we have a vigorous collaboration with Rajesh and Daniel in here. So thank you for your in-person. JD is working. I think there is a lot. I think my collaboration strength is quite, because when I come in here, there is not much laboratory, no laboratory with me. So I work with them and extend my collaboration. Of course, the funding, without funding, that this work will not be possible. The work I present only maybe 10 or 20% maximum. There is a lot of work actually happen. And finally, thank you, Nami Hinui, Dhanyabad. Dhanyabad is a Bengali. It's again called the thank you. Thank you very much for your time.
Thank you very much. Thank you so much. Namhi ko Pitikathru Toko Wingawa. I'm the head of the Department of Oral Rehabilitation. It's a huge pleasure being here today and tonight. But first of all, thank you very much, Professor Diana Sika-Paratonu, Deputy Vice-Chancellor, and Professor Paul Cooper for being here. Secondly, thank you, Azam. I always love these evenings because you start to learn more and more and more about the person and hearing your journey, and it's just amazing. There's so much I just did not know that you have done, and it's a real privilege to hear that tonight. I really enjoyed hearing about your early years, being a little baby right through, your passion for chemistry, and that you became involved with research, all the days from the atomic energy. Thankfully, you didn't stay with atomic energy, and that you morphed into innovation, commercialization, and in particular, the many years dedicated to clinical research with wool. You've clearly created value, extra value to wool, from those super nappies, which hopefully one day I will never need, but I will thank you if I do. Right through to wound dressings, one day, I hope I never need them, but I will thank you if I do need them. So huge breadth of research and implications from all values of life, so thank you. Since coming to the Faculty of Dentistry in the Department of Oral Rehabilitation in 2021, I really appreciated your willingness to engage, collaborate. Every time I've asked you, Azam, would you mind doing this? You've just said yes. What can I do? What can I do more? And that's just gold. So thank you for that. You've been positive in your teaching, in your research, your supervision. Almost every department there's been a touch of you, and I thank you for that positive contribution. And it's testimony to see all those students there, your co-collaborators, and the way you can bring people together, a very strong strength. You have made, indeed, a positive and meaningful contribution to global research that has resulted in products and improved treatment outcomes for patients. You have indeed made a positive and meaningful contribution to educating the future healthcare professionals. I'm glad that you ended up in our department. I really am. I enjoy working together, and I look forward to many years ahead. Thirdly, I do thank you, the audience, family, friends, colleagues, for the support that you've given Azam over these years, and we can't be here without that, so thank you for that. So on behalf of the university, we do have a token to thank you for as an appreciation, so I will hand that over to you now. So, Professor Azam Ali.